Okay, in this video I'm just going to show you the linear interpolation method for getting medians and percentiles. So, as ever, understand what the data means. This column of data means that there were 9 people. The data is about heights to the nearest centimetre, so these 9 people, their heights rounded to the nearest centimetre were from 155 to 164 centimetres. Now, before I can do anything with this data, I need to deal with the fact that the data has been rounded. We have this gap between 154 and 155 where people will have been rounded up or rounded down. So the true cutoff point, anyone up to 154.5 would be in the first category. So that's going to have a true upper class boundary of 154.5, and that's going to be the lower class boundary of the next group up. So the first thing to do is to complete all of the true class boundaries, like that. Then we need to, because we're working with medians, we are interested in the positions within the data. We know there are a total of 30 people. We need to add up step by step to work out the cumulative frequencies. So for the first category, up to 154.5, I've just got these 5 people. But up to 164.5, I've got these 9 as well. So we've got a total of 14 people, and we complete our cumulative frequencies just by adding the next group on. So 25 and then 30 people altogether. Okay, now I'm ready to try and find the median. So for the position of the median, so the median position, okay. Now, because of the approximations we're doing in this work, all right, we don't do that thing where we add 1 to the number of people before dividing. We just go, it's 30 people, and the median is halfway through them, so we can just do 30 divided by 2. So we're looking for the 15th person, okay? Now, I can see, looking at my cumulative frequencies, that by the time I reach the 14th person, okay, I have got up to a height of 164.5, but I want the 15th person, so the 15th person would be someone in this group here. And we can see that it's only just into this group, so out of these 7 people, effectively, I just want to go to the first person. So I'm going to go 1/7 of the way into that group. Now, this is the bit that people find a little bit confusing. Okay, so we need to think about visualizing this situation. So what we can do is we can imagine lining up all of our people in order of height. Now, unfortunately, a photograph of 30 people, which is what we've got, wouldn't look very good. So this is the kind of situation, but let's represent the people by bars. So here we go. We've got our 30 people lined up, okay, as bars, and we've got their heights, but I can't really read off that scale. I'm going to have to get my data from the table. But what we're trying to do is find the median height out of 30 people, and that median height is in 15th position, okay? So I'd really like the height of this bar, but I can't use the scale, so I have to use data from the table. So the cumulative frequency tells me by the time I get to the 14th person, I've reached a height of 164.5. And then by the time I reach the 21st person, their height I'm estimating as 174.5. So I can put that data on my diagram. So this is what we've got. The 14th person with a height of 164.5 is here. The 21st person with a height of 174.5 is here. And I want to estimate the height of this 15th person. Okay. Now, the table gives me no information about where the heights are here, what they are, but they look like, most of the time, I'll expect them to go up fairly steadily. So what we do is we assume we have a straight line. That's why it's called linear interpolation. So I'm going to use effectively a straight line to estimate how far up. I clearly have to go a little bit up from 164.5 to estimate the height of this 15th person. So what I'm going to do is I'm just going to draw another diagram that shows important information. How far we've gone across, how far we've gone up. So that simplified diagram looks like this. So here's my simplified diagram. Okay, I'm going from the 14th person to the 21st person, and as I go from the 14th person with a height of 164.5, as I go up to the 21st person, I reach a height of 174.5. But our median was the 15th person. So what we've got to do is use this diagram to estimate the height of the 15th person. Now, once you've drawn this diagram, actually, there are lots of ways you can draw similar triangles. You can use proportional reasoning. If you want to draw this diagram and use your own method from it, as long as you know that it works, that's fine. But we're working towards a method where hopefully we can just write down the answer as a calculation without having to draw the picture. So I'm working towards that way. So the way that we are going to use, or I'm going to discuss, thinks about what proportion, what fraction of the way across we've come. So we can see there's a total gap across from here to here of 7. But I only want to come across one unit, one person. So I'm coming 1/7 of the way across. So if I'm coming 1/7 of the way across this triangle, I want to get up to this height here. So this height here is going to be my estimated median. Okay, so how far do I have to go up to get to that median? Well, the idea is if we come 1/7 of the way across, we have to go 1/7 of the way up. So I need to do 1/7 of the gap. And the gap is, well, we can see it's 10, but the way we'd work out the 10 is 174.5 minus 164.5. Okay, so if I'm going 1/7 of the way up that gap, I need to do 1/7 times is 10, so it's going to be 10/7. Okay, and 10/7 as a decimal is 1.429 to 3 decimal places. So that's how far I need to go up. So my median is going to be 164.5, okay, plus this 1.429, okay, but I'm going to write 1/7, 174.5 minus 164.5, because that shows us the full method, okay, but in the end I'm going to be doing 164.5 plus 1.429, which is going to give me 165.929. Now that's probably a stupid amount of accuracy. We'd probably give this correct to either 3 significant figures or maybe 1 decimal place. So you'd give your answer either as 166, or if you really want to give lots of accuracy, 165.9 centimeters. Okay, but we're home. That's our estimate of the median. Okay, so what we need to do is look at this expression here and think, how could we write this expression down? How can we think about this without having to actually draw the picture every time? So let's go back to our table. We know the median position is 15. We know that by the time I reach the 14th position, I've reached a height of 164.5. Okay, and by the time I get to 174.5, I'm way past the 15th. So somewhere between the 14th and the 21st person, I'll find the 15th. So I need a height between 164.5 and 174.5. So it's going to be, the median is going to be estimated as approximately equal to 164.5. Okay, and then I need to be going part of the way from the 14th person to the 21st person, okay, which is 7 people, but I only need to go 1 extra person. So this is up 1 from the 14th. Okay, so I need to go 1 step up, 1 person up, out of, there are 7 people in this next group. Okay, here they are. There's 7 people between 164.5 and 174.5. So I need to go 1/7 of the way, because I don't need to go far on from the 14th person. And then I now need to think about the heights of these 7 people. The heights increase from 164.5 to 174.5, which is a gap of 10, or I can work it out as 174.5 minus 164.5. So I need to do 1/7 of that gap. And that calculation there is exactly the same calculation as we came up with this one from the diagram. If the diagram helps and you want to draw it and that helps you get this calculation, that's fine. But the explanation I've just given, you might want to replay it, okay, gives you a way of writing this down directly. You can type this into your calculator which gives an answer of 165.9 centimetres, as I've very badly written here. 165.9 is what I mean. Okay, so that was the median. So let's go on and do the 35th percentile. Okay, so the 35th percentile position, okay, well, the median position, I know that that's 50% of the way through the data, so I did 30 divided by 2. For the 35th percentile, I need to find 35% of the way through the data. So that's 0.35 for 35%, and there are 30 heights, so I do 0.35 times 30. So I need to find position 10.5 in the data. Okay, so looking at the cumulative frequencies, by the time I've had the first 5 people, I'm up to a height of 154, but then by the time I've got 14 people, I've passed the 10.5th, so somewhere between these two will be the 10.5th person. So it will be in this group. Okay, the 10.5th person will have a height of 154.5, because that's the height of the 5th person, and the height of the 14th person will be 164.5. So I need to be adding on to 154.5. Okay, I need to be adding on part of the gap of heights. So the heights in this group increase from 154.5 to 165.4.5, okay, which again is 10, but the calculation would be this, 154.5. So that's the overall gap. If I went all 14 people of the way through this gap, I'd climb from 154.5 by a distance of 10 to this. But I don't want to go all the way through this gap. Okay, there are 9 people in this group. I need to climb from the 5th person to the 10.5th person. So this 10.5th person, I need to think what it is up from the 5th person. So by the time I enter this group, I've already had 5 people. So how many more people do I need? Well, I need to get up to the 10.5th person, so I need to go 5.5 people up from the 5th person. Okay? So that means the proportion of the gap I need is going to be 5.5 people out of the number of the people between these, which is this 9. So that's why I need to do 5.5 ninths times the gap between the categories. So all you then have to do is enter this calculation into your calculator. And I make that 160.1 centimetres. So that's what I'm going to state as my 35th percentile. Okay, now I could do that same calculation using the diagram again. So here I've got the 5th person with their height of 154.9, the 14th person with a height of 164.5, those are the numbers from the table, and the 10.5 is the position of that 35th percentile. So again, I'm thinking of the fraction of the way across I need to come. I've got a gap across of 5.5, but the total gap across is 9, so that's why I'm doing a fraction of 5.5 ninths. And I need to go up the same fraction of the way from 154, so I need to start at 154.5, that should say. 154.5. Okay, I need to start at 154.5. I'm doing it here, 154.5, and I'm adding on this distance here. And this distance here will be the correct proportion, 5.5 ninths of the gap between these, which is 10. Yeah, 164.5 minus 154.5. So that produces the same calculation that we had before to get that answer of 160.1 centimetres. So I hope that that spells out in a little bit more clearly for you how we use linear interpolation to get medians and percentiles.